There are four basic properties of wave characteristics: amplitude, wavelength, speed, and phase constant. Amplitude, the maximum amount of displacement or the maximum amount of volume before it distorts. Wavelength, the distance in meters between corresponding points where the wave repeats. Speed, the time rate of change of position of a form in meters or seconds. Phase constant, shifts the wave in position and or time. As we look at our diagram, we can tell various points and positions of a frequency wave. First, we have a trough. A trough is a reduction or a decrease in volume from a frequency wave. Next, we have a wavelength. A wavelength tells us how fast or slow a frequency wave is moving. Next, we have a peak. A peak is the opposite of a trough. It lets us know that we do have volume in a frequency wave. And lastly, we have amplitude. Amplitude tells us how loud a frequency wave can get before distortion. As we look at our next diagram, we can tell that there are four different types of waves: a sine wave, a square wave, a triangle wave, and a sawtooth wave, in which they all reproduce their own distinctive sound. Let's do a tone test and hear what it sounds like. In our next diagram, we can see more properties of a frequency wave. First, we have a high frequency wave. Next, we have a mid frequency wave. And lastly, we have a low frequency wave. Each frequency has a defined measurement in its speed, measured in hertz or kilohertz, which are the amount of cycles per second. A high frequency range has a frequency range of 20 kilohertz to 5 kilohertz. A middle frequency range has a range of 5 kilohertz to 200 hertz. A low frequency range has a range of 200 hertz to 20 hertz. A high frequency range has a maximum amount of peaks, which means that the frequency wave moves fast. And that also means that it moves in a straight direction, which makes it a directional frequency. A low frequency has a slower peak-to-peak frequency, which means that it is a omnidirectional frequency because it has more time to bounce all around, which gives us our sounds of bass and subwoofers. The middle frequency is somewhere in between. The human hearing of frequency ranges are 20 hertz to 20 kilohertz, which is actually pretty good. But there is a species that hears a little bit more better than we do, which are dogs. They hear up to 30 kilohertz. As we look at our next diagram, we can see the human ear. The human ear has three distinct properties: the outer ear, the middle ear, and the inner ear. In its simplest terms, the outer ear works like a funnel. It transfers sound pressure levels to the middle ear. The middle ear works as a hammer. It only reproduces the amount of pressure it's hearing. The inner ear works with the brain system. It tells the brain whether you're hearing a high, mid, or low frequency. Have you ever wondered why an object can shatter? The reason why is because each object, matter, or property has a distinctive resonant frequency. Each resonant frequency that matches the opposite resonant frequency at an amplified volume level can basically shatter or destroy the opposite resonant frequency. In our next example, we will see how high, mid, and low frequencies make distinctive geometric patterns. So, what is sound and where does it come from? Sound comes from a high level of sound pressure level. Even though we cannot see them, there are large amounts of air molecules. When we speak, we apply pressure to those molecules, which gives us the vibrations of what we hear. The first initial sound pressure level is normally the loudest, but every 2 frequencies, it reduces down about 6 levels in meter volume. How much sound pressure level is too much sound pressure level? Well, we measure that in dB, or decibels. 0 dB to 60 dB is around about a whisper level. 70 dB to about 80 dB is conversational level. 90 dB is where we get into rock concerts and hip-hop concerts type levels. And 120 dB is deafening, and you can damage your eardrum tissue and all the above. So please wear earplugs.